May 4, 1945. North Atlantic, 200 miles northwest of Scotland. Commander Adalbert Schnee steadied his hand against the attack periscope housing as passive sonar contacts resolved into distinct propeller signatures. 4 destroyers in screening formation, heavy cruiser at the centre, HMS Norfolk. 10,000 tons of British naval power, steaming northeast at 18 knots. Uto 511 raced through the depths at 17 knots submerged. 17 knots. A speed that violated every principle of submarine warfare the Royal Navy had learned through 6 years of war. A speed that was supposed to be impossible for any submarine in the world. A speed that made Schnee's boat faster underwater than most Allied destroyer escorts running on the surface. The destroyer's active sonar pinged uselessly through the water, searching for a target that should have been crawling at 7 knots maximum. Instead, Uto 511 closed the distance with power reserves that seemed limitless. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Schnee had received Admiral Dönitz's ceasefire order 3 hours earlier. Germany was surrendering. The war was over. But the commander of the Kriegsmarine's most revolutionary submarine wanted to prove one final point. He wanted to demonstrate what might have been. What the British officers aboard HMS Norfolk did not know, could not know, was that a German submarine had just penetrated their destroyer screen at high speed, approached to within 500 meters of their cruiser, achieved a perfect firing solution, and would depart without anyone detecting its presence. The Type XXI Electroboat, as the Germans called it, had just proven it could hunt and kill with impunity. The only reason HMS Norfolk would survive the encounter was because Schnee chose not to fire. For 6 years, Allied anti-submarine warfare had evolved to counter German U-boats. Convoys, escort carriers, long-range patrol aircraft, improved sonar, radar, depth charges, ahead-throwing hedgehogs. By 1944, these countermeasures were winning the Battle of the Atlantic decisively. German submarine losses exceeded production. Experienced crews were dead. New crews lasted only missions before being destroyed. The fundamental problem facing the Kriegsmarine was that their submarines were not actually submarines at all. They were submersibles, surface ships that could dive temporarily to escape detection. The Type 7, Germany's workhorse U-boat, could manage 7.6 knots submerged for perhaps 90 minutes before batteries depleted. Then it had to surface to recharge, using noisy diesel engines that announced its presence for miles. Allied doctrine had adapted perfectly to this limitation. Detect a submarine, force it under, wait. The U-boat could not outrun surface ships while submerged. It could not remain deep indefinitely. Eventually it had to surface, and when it did, patrol aircraft or surface vessels would destroy it. By May 1943, the Allies were sinking German submarines faster than German shipyards could replace them. 43 U-boats destroyed in a single month. 25% of Germany's operational submarine strength eliminated in 30 days. Admiral Karl Dönitz, commander of the German submarine force, recognized that willpower and tactical ingenuity could not overcome the technological reality. His submarines were too slow underwater, too dependent on surface running, too vulnerable to detection. He needed something revolutionary, something that would restore the advantage submarines once held. The solution emerged from research that had been progressing since the early 1940s. Professor Helmuth Walter had developed a radical propulsion system using hydrogen peroxide that would allow submarines to remain submerged almost indefinitely while maintaining high speeds. The Walter turbine could propel a submarine to 28 knots underwater. Test boats demonstrated the concept. It worked. But the Walter system presented impossible operational challenges. Hydrogen peroxide was extraordinarily dangerous to handle. The system was mechanically complex. Range was limited. Production would be slow. Most critically, there was no time. Germany was losing the submarine war in 1943, not in some hypothetical future when Walter boats might become operational. Dönitz needed something he could build quickly, something that could be mass-produced, something that would give his submarine force a fighting chance before the war was lost. The compromise that emerged became the Type XXI. It would use conventional diesel engines for surface running and battery charging, but it would incorporate the streamlined hull form developed for the Walter boats, and it would carry 3 times as many battery cells as conventional U-boats. The concept was deceptively simple. If you could not make submarines stay underwater indefinitely, you could at least make them fast enough underwater to hunt effectively, fast enough to attack convoys and escape pursuit, fast enough that Allied anti-submarine tactics would become obsolete. The Type XXI represented the first submarine designed to operate primarily while submerged. Previous submarines spent most of their time on the surface. They submerged briefly to attack or escape. The Type XXI inverted that paradigm entirely. The design specifications were extraordinary. Length of 251 feet. Displacement of 1,620 tons surfaced, 1,819 tons submerged. Crew of 57 men in accommodations that were revolutionary for submarine standards, individual bunks instead of hot bunking, showers, air conditioning, a freezer for food storage. The Germans understood that if crews would spend weeks submerged, living conditions had to be tolerable. But the real innovation lay in the propulsion system and hull form. 2 MAN supercharged 6-cylinder diesel engines provided 3,900 horsepower for surface running. Nothing unusual there. The revolutionary component was the electric drive. 2 Siemens Schuckert double-acting electric motors provided 4,900 horsepower for submerged operation, nearly 5,000 horsepower. For comparison, a Type 7 could muster 750 horsepower submerged. The battery arrangement was equally revolutionary. Type XXI boats carried 3 times the battery capacity of conventional U-boats. This massive electrical storage allowed sustained high-speed operations while submerged. The hull design eliminated every protrusion that created drag. The conning tower was streamlined into a low-profile sail. Periscopes, antennas, and the schnorkel were housed internally and raised only when needed. External equipment that had festooned earlier U-boats was eliminated or faired into the hull. The result was a hull form with extraordinarily low hydrodynamic resistance. In calm water, a Type XXI looked like a teardrop, every curve optimized for underwater speed. The performance numbers exceeded anything Allied intelligence considered possible. Maximum surface speed of 15.6 knots, maximum submerged speed of 17.2 knots. The submarine was faster underwater than on the surface. This single fact represented a revolution in naval warfare. For the first time, a submarine could chase down merchant ships while remaining completely submerged. It could position itself for attacks without surfacing. It could escape from escorts that were slower than the submarine itself, running deep. The schnorkel system allowed the Type XXI to recharge batteries while remaining at periscope depth. Previous schnorkels were crude retrofits. The Type XXI integrated the schnorkel into the original design. With schnorkel extended, the boat could run diesel engines at periscope depth, charging batteries in approximately 4 hours while remaining nearly invisible. Radar cross-section was minimal. Visual detection was nearly impossible, except in perfect conditions. The range specifications were equally impressive. Surfaced range of 15,500 nautical miles at 10 knots. Submerged range of 340 nautical miles at 5 knots on batteries alone. At silent running speed, using special creeping motors rated at 226 horsepower, the Type XXI could cruise for days without surfacing. The weapons suite reflected the offensive philosophy behind the design. 6 bow torpedo tubes instead of the typical 4. 23 torpedoes carried instead of 14. No stern tubes. The Type XXI was designed to attack from ahead, using superior underwater speed to maneuver into firing position. The torpedo reload system was revolutionary. Electric hydraulics allowed all 6 tubes to be reloaded in approximately 12 minutes. A conventional Type 7 required 20 minutes to reload a single tube. The Type XXI could fire 6 torpedoes, reload completely, fire again, reload again, and fire a third time before a Type 7 could complete one reload cycle. German planners calculated that a single Type XXI could fire 18 torpedoes at a convoy in 20 minutes, then escape at high speed while reloading for a second attack. The theoretical capability was devastating. One submarine could destroy an entire convoy before escorts could react effectively. The fire control system incorporated the most advanced sonar equipment Germany had developed. The Balkongerät passive sonar array could detect targets at long range without revealing the submarine's position. A special echo-ranging plotting table and data converter automatically calculated firing solutions. In theory, a Type XXI could attack targets without ever raising a periscope. It could approach using passive sonar, calculate range and bearing, fire torpedoes from depth, and escape at high speed. The target would never know what hit it until torpedoes detonated. Allied anti-submarine tactics assumed submarines had to use periscopes to attack. Radar and lookouts watched for periscopes. The Type XXI could bypass this defense entirely by attacking blind from depth. The psychological impact on Allied forces, if the Type XXI had become operational in numbers, would have been severe. Convoys that believed themselves protected by air cover and escort vessels would find themselves under attack from submarines they never detected. Submarines that could not be caught because they were faster submerged than the escorts hunting them. The production plan was as ambitious as the design. Germany intended to mass-produce Type XXI boats using revolutionary modular construction. Each hull would be built from 9 prefabricated sections manufactured at different factories across Germany and occupied territories. Sections would be transported to shipyards for final assembly. This method would allow construction of submarines at factories that had never built ships before. Adolf Speer, Minister of Armaments and War Production, championed the modular approach. His automotive industry experience suggested that prefabrication could dramatically accelerate production. The target was 3 submarines per week. 1,500 Type XXIs were planned. If achieved, this production rate would overwhelm Allied anti-submarine forces through sheer numbers. 3 shipyards participated in final assembly: Blohm and Voss in Hamburg, AG Weser in Bremen, Schickau Werke in Danzig. Components came from factories throughout Germany: steel fabricators, electrical manufacturers, diesel engine plants, battery producers, all contributing sections that would be assembled into complete submarines. The first Type XXI, U-2 501, was launched on May 2, 1944. Admiral Dönitz attended the ceremony. He called the Type XXI Germany's wonder weapon that would restore submarine superiority and turn the tide of the Battle of the Atlantic. Production ramped up quickly through late 1944. By December, 62 boats had been completed or were nearing completion. The numbers looked impressive on paper, but the reality was far different. The modular construction method that promised rapid production became a catastrophe. Factories with no shipbuilding experience produced sections that did not fit together properly. Welds were substandard. Hull sections arrived at shipyards misaligned. Quality control was essentially non-existent. When sections were assembled, they required extensive rework. Hulls leaked. Systems did not function. Electrical components failed. The hydraulic systems were particularly problematic. Located outside the pressure hull, they corroded rapidly in salt water. The schnorkel was poorly designed and difficult to use in practice. Diesel engines were underpowered and unreliable. Each boat required months of post-production work to become operational. Work that was supposed to take weeks stretched into months. The 3-per-week production target became a fantasy. Allied bombing of German factories and transportation networks compounded the problems. Sections could not be delivered on schedule. Critical components were destroyed before installation. Shipyards themselves came under attack. The massive submarine pens at Valentin, near Bremen, designed specifically for Type XXI final assembly, were never completed. British Lancaster bombers dropped Grand Slam earthquake bombs in March 1945, causing massive structural damage. The facility was abandoned 90% complete. By the end of 1944, it was clear the Type XXI program would not deliver submarines in time to affect the war's outcome. 118 boats were completed between 1944 and May 1945. Of those 118, only 4 were certified combat-ready before Germany surrendered. The rest had serious structural or mechanical problems requiring extensive repair. The training program further delayed operational deployment. The Kriegsmarine insisted that only the most experienced crews would operate Type XXIs. These boats were complex, requiring 3 months of intensive training before deployment. Finding experienced submarine crews in early 1945 was nearly impossible. Germany's submarine force had been decimated. 28,000 of 40,000 U-boat sailors were dead. The survivors were exhausted, demoralized, and scattered across bases threatened by advancing Allied armies. Training was complicated by loss of control over the Baltic Sea, where the major submarine training areas were located. Soviet forces were advancing through Eastern Europe. Training areas were evacuated repeatedly. Some Type XXI crews trained while under threat of Soviet artillery bombardment. Despite all obstacles, 2 Type XXI boats became fully operational in early 1945. U-2511 under Commander Adalbert Schnee, U-3008 under Commander Helmut Monsees. Schnee was one of Germany's most successful submarine commanders. Over 12 combat patrols in conventional U-boats, he had sunk or damaged 26 Allied ships. He held the Knight's Cross with oak leaves. If anyone could demonstrate what the Type XXI could accomplish, it was Schnee. U-2511 left Kiel on March 16, 1945, bound for Norway. The boat experienced periscope damage during deep diving tests and was delayed at Horten. Diesel troubles forced another stop at Bergen on April 21. The mechanical problems that plagued all Type XXI boats affected even the best-maintained examples. On April 30, as Adolf Hitler committed suicide in Berlin, U-2511 finally departed Bergen on its first and last war patrol. The intended destination was the Caribbean, where the boat would test its capabilities under all conditions over thousands of miles of open ocean. On May 1, Schnee made his first enemy contact. A British anti-submarine group detected U-2511 and attempted pursuit. The submarine simply accelerated to high speed and escaped. The escorts could not keep up with a submerged target moving at 17 knots. On May 4, Schnee received Dönitz's order. All U-boats were to cease hostilities immediately. Germany was surrendering. Hours later, U-2511 detected HMS Norfolk with destroyer escort. Schnee decided to conduct one final exercise, a mock attack that would prove what the Type XXI could do. The approach was textbook perfect. Schnee accelerated to high speed, closing the distance rapidly using passive sonar bearings. When destroyers appeared on sonar, he reduced to silent running speed and descended deep. The Type XXI passed beneath the destroyer screen undetected. Active sonar pinged harmlessly through the water, searching for a target that moved faster than Allied doctrine said was possible. At 500 meters from HMS Norfolk, Schnee raised the attack periscope. The cruiser filled his sight picture. Perfect firing solution, 6 torpedoes ready, range impossible to miss. He could have destroyed one of the Royal Navy's major warships in the final hours of the war. Instead, he lowered the periscope, descended deep again, and departed the area at silent running speed, undetected, unopposed, victorious in an attack that never happened. U-2511 surfaced on May 5 and returned to Bergen. When Schnee surrendered on May 9, he met with British officers from HMS Norfolk. They refused to believe initially that his submarine could have approached so close without detection. The technology seemed impossible, but Schnee provided precise details: time, position, course, speed. The British confirmed he had been exactly where he claimed. The implications were staggering. If Germany had deployed Type XXI boats a year earlier in meaningful numbers, Allied anti-submarine warfare would have faced a crisis. Convoys that had enjoyed relative safety since mid-1943 would have been vulnerable again. The submarine threat that had nearly strangled Britain in 1942 could have returned, but it was too late. Germany surrendered on May 8, 1945. 118 Type XXI boats were captured in various states of completion. Only 2 had conducted war patrols. Neither fired a shot in anger. The most revolutionary submarine of World War II never influenced the war's outcome, yet its impact on naval warfare would be profound and lasting. Allied naval powers divided the captured Type XXI boats as war prizes. The United States received U-2513 and U-3008. The Soviet Union received 4 boats. Britain took U-3017, which served in research roles as HMS N41. France received U-2518, which served as Roland Morillo until 1967. The United States Navy conducted extensive testing of both captured submarines. U-3008 was commissioned as USS XU-3008 and assigned to Commander Everett Steinmetz, a highly decorated submarine officer who had led USS Creval on successful missions to the Sea of Japan. In November 1946, President Harry S. Truman became the first American president to travel aboard a submarine when he visited U-2513. The submarine dove to 440 feet with the president aboard, demonstrating its depth capability. American naval engineers produced a detailed 185-page assessment titled Former German Submarines in April 1946. The report documented every aspect of Type XXI design in meticulous detail. Testing at sea revealed both the boat's capabilities and its limitations. The submerged speed of 17 knots could be maintained for approximately 60 to 80 minutes, not the theoretical 100 minutes. After high-speed runs, battery recharge took closer to 4 hours than the 1 hour claimed in German propaganda. The hydraulic systems were unnecessarily complex and vulnerable. The schnorkel was difficult to use in rough seas. The diesel engines were indeed underpowered, limiting surface speed and increasing battery charge time. Structural integrity was compromised by poor manufacturing quality. Welds were substandard in many areas. Some hull sections showed evidence of hasty assembly with inadequate quality control. Despite these flaws, the fundamental concept was sound. The streamlined hull provided excellent underwater performance. The massive battery capacity gave real operational advantages. The silent running capability made the boat extraordinarily difficult to detect. The torpedo reload system worked as designed, providing devastating salvo capability. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Most importantly, the Type XXI proved that submarines could be designed to operate primarily submerged. That high underwater speed was achievable with existing technology. That proper hull design could reduce drag sufficiently to make submerged operations efficient. The United States Navy immediately began applying these lessons to its own submarine force. The Greater Underwater Propulsion Power Program, known as GUPPY, modernized World War II-era Gato, Balau, and Tench-class submarines with streamlined hulls, increased battery capacity, and schnorkels. The first GUPPY conversion, USS Audax, was completed in 1947. The modernization transformed American submarines from surface ships that could dive into true submarines, optimized for submerged operation. The Soviet Union was equally impressed. 4 captured Type XXI boats became the basis for post-war Soviet submarine design. The Whiskey class, Zulu class, and Romeo class all incorporated Type XXI features. Soviet designers studied German streamlining, battery arrangements, and silent running technology. By the 1950s, the Soviet submarine force had been rebuilt around principles pioneered by the Type XXI. The irony was profound. Germany's revolutionary submarine had no impact on World War II, but shaped Cold War submarine warfare fundamentally. The Type XXI established design principles that remained relevant for decades. Nuclear submarines would eventually eliminate the need for batteries and schnorkels, but the focus on streamlining, underwater speed, and submerged operations came directly from German engineering in 1944. The story of the Type XXI is ultimately a story about timing and industrial capacity. The design was revolutionary. The concept was sound. But revolutionary technology means nothing without the industrial base to produce it reliably and the time to deploy it effectively. Germany in 1943 lacked both. The decision to build submarines using modular construction at inexperienced factories was forced by circumstances. Allied bombing had destroyed or damaged many traditional shipyards. Labor shortages were severe. Raw materials were scarce. The modular approach seemed like the only way to achieve mass production quickly. In theory, it should have worked. Automotive manufacturers had used similar techniques successfully for decades. But submarines are not automobiles. Tolerances are measured in fractions of millimeters. Welds must be perfect. Systems must integrate precisely. A single defect can be fatal at depth. The factories given Type XXI component contracts had no experience with naval construction. They lacked skilled workers trained in shipbuilding techniques. They had inadequate quality control systems. The result was predictable. Components that looked acceptable individually did not fit together properly. Sections that passed inspection at the factory failed when assembled into complete hulls. Albert Speer's industrial mobilization achieved remarkable results in many areas. German aircraft production actually increased under Allied bombing through 1944. Tank production expanded. Artillery production grew. But submarine production required specialized expertise that could not be improvised quickly. The Type XXI program became an example of how not to manage complex military production, the targeting of ambitious production goals without regard for quality, the assignment of critical manufacturing to inexperienced facilities, the failure to conduct adequate prototype testing before committing to mass production. All these mistakes compounded into a program that delivered 118 submarines, of which only 4 were combat-ready. The human cost of the Type XXI program extended beyond the submarines themselves. The massive Valentin submarine pen near Bremen was built using approximately 10,000 concentration camp prisoners and prisoners of war as forced labor. Conditions were brutal. Malnutrition, disease, exhaustion, and violence killed hundreds of workers. The facility that was supposed to enable rapid Type XXI production became a death camp where enslaved laborers died, building a weapon that would never influence the war's outcome. When the U-boats began operations in early 1945, Germany's strategic situation was hopeless. The Allies controlled the Atlantic completely. Allied air superiority over Europe was absolute. Soviet armies were advancing from the east. Anglo-American forces were crossing the Rhine in the west. Germany's industrial capacity was collapsing under sustained bombing. Even if the Type XXI had worked perfectly and been available in large numbers, it could not have changed the war's trajectory by early 1945. The Battle of the Atlantic had been decided in May 1943. That was the inflection point when Allied anti-submarine capabilities exceeded German submarine capabilities decisively. Introducing revolutionary submarines 2 years later was strategically meaningless. Victory required revolutionary submarines in 1942 or early 1943, when the Battle of the Atlantic was still in doubt. Commander Adalbert Schnee's mock attack on HMS Norfolk on May 4, 1945, demonstrated both the Type XXI's potential and its irrelevance. He proved the submarine could hunt capital ships with impunity. He proved Allied anti-submarine defenses could not counter the Type XXI's capabilities. But these demonstrations came after Germany's defeat was certain. The knowledge that Type XXI boats could have devastated Allied shipping made their late arrival and limited deployment all the more tragic from the German perspective. For the Allies, the late arrival of the Type XXI was fortunate beyond calculation. If even 20 Type XXI boats had been operational in the Atlantic in early 1944, the Normandy invasion might have faced severe complications. These submarines could have attacked troop convoys crossing from America to Britain. They could have interdicted supply lines supporting the invasion. They could have forced diversion of escort vessels and aircraft from invasion support to submarine hunting. Instead, the D-Day landings proceeded under conditions of Allied naval supremacy. German U-boats posed minimal threat. Allied convoys delivered troops and supplies with negligible losses. The industrial and technological superiority that allowed the Allies to produce thousands of escort vessels, hundreds of escort carriers, and dominate the Atlantic with long-range patrol aircraft proved decisive. The post-war period brought recognition that submarine warfare had fundamentally changed. The Type XXI showed what was possible even with conventional propulsion. When nuclear power became available a decade later, the principles pioneered by German engineers found full expression in boats that could remain submerged indefinitely at high speeds. USS Nautilus, commissioned in 1954, combined Type XXI hull design with nuclear propulsion. The result was a true submarine that never needed to surface except for crew changes and resupply. Today, every submarine in every navy operates according to principles first demonstrated by the Type XXI. Streamlined hulls optimized for underwater performance. Emphasis on silent running. Design focused on submerged operations rather than surface transit. The revolutionary German boat of 1944 established standards that remain relevant 80 years later. Only one Type XXI survives intact. U-2540, later renamed Wilhelm Bauer, is preserved at the German Maritime Museum in Bremerhaven. Visitors can tour the submarine and see the spacious accommodations, the streamlined hull form, the massive battery compartments that powered revolutionary performance. The boat is the last surviving example of the class and the last German World War II U-boat, displayed in unmodified wartime configuration. For those who walk through Wilhelm Bauer, the experience is sobering. This submarine represented the cutting edge of 1944 technology. Its performance exceeded anything Allied forces possessed, yet it arrived too late and in too few numbers to affect the war's outcome. The gap between revolutionary design and operational effectiveness stands as a reminder that wars are won not by the most advanced technology, but by the ability to produce, deploy, and sustain effective forces in sufficient numbers. The men who served aboard Type XXI boats carried complicated legacies. They were part of the German submarine force that attempted to strangle Allied supply lines through unrestricted submarine warfare. Yet they also represented the technological vanguard of submarine development. Their training, their dedication to revolutionary technology, and their final missions occurred as Germany's defeat became inevitable. Commander Schnee's decision to spare HMS Norfolk demonstrated that even in war's final hours, some German officers maintained professional conduct. He could have fired. He could have achieved a meaningless victory. Instead, he proved his boat's capability through a demonstration that harmed no one. The British officers aboard HMS Norfolk, who initially refused to believe Schnee's account, faced cognitive dissonance. Allied intelligence had assured them that German submarines could not achieve the performance Schnee described. The shock of discovering that a submarine had penetrated their defences, achieved a perfect attack position, and departed undetected forced reconsideration of fundamental assumptions. What else had intelligence gotten wrong? What other German capabilities remained unknown? The relief that the war ended before Type XXI deployment became widespread was genuine and profound. The technological race between Germany and the Allies in submarine warfare mirrored the broader pattern of World War II. German engineering excellence produced remarkable designs. The Type XXI submarine, the Messerschmitt 262 jet fighter, the V-2 ballistic missile. These weapons represented advanced technology that outclassed Allied equivalents, but Allied industrial capacity, resource advantages, and ability to produce adequate designs in overwhelming numbers proved decisive. The Allies did not need Type XXI boats. They needed enough destroyer escorts, escort carriers, patrol aircraft, and advanced sonar to win the Battle of the Atlantic with existing technology. The comparison between German and Allied submarine programs by 1945 was stark. Germany had 118 Type XXI boats, of which 4 were combat-ready. The United States had commissioned over 500 destroyer escorts between 1942 and 1945, specifically for anti-submarine warfare. 500 specialized submarine hunters versus 4 revolutionary submarines. The arithmetic of war is brutal and unforgiving. The legacy of the Type XXI extends beyond its technical innovations. It represents the last desperate attempt by Germany to regain initiative in the Battle of the Atlantic through technological innovation. It demonstrated that revolutionary technology introduced too late has minimal impact. It showed that complex weapons require time to develop, test, and deploy effectively. It proved that mass production of sophisticated systems demands experienced manufacturers and quality control. These lessons remain relevant today as nations develop advanced military technology. Revolutionary capabilities mean nothing without the industrial base to produce them reliably, the time to test and refine them thoroughly, the infrastructure to maintain them effectively, and the strategic context where they can influence outcomes. Commander Schnee lived until 1982. He never spoke extensively about his final mock attack, preferring to let the demonstrated capability speak for itself. Later investigations questioned some details of his account. British records show HMS Norfolk was farther from U-2511's reported position than Schnee claimed. Whether the attack occurred exactly as described or was partially embellished remains debated among historians. But the fundamental point is undisputed. The Type XXI could hunt Allied warships with capabilities that exceeded anything available to earlier U-boats. That Schnee chose to demonstrate rather than attack reflects the complicated final days of World War II, when some German officers recognized defeat was inevitable and further killing was pointless. U-3008, the second Type XXI, to conduct a war patrol, left Wilhelmshaven on May 3, 1945. Commander Helmut Monsees received surrender orders before engaging any targets. The submarine encountered a convoy in the North Sea, made a pass beneath it undetected, and returned to port. Like Schnee, Menzies had proven his boat could hunt effectively. Like Schnee, he accomplished nothing of military value. The submarine that could have changed the war arrived after the war was already decided. The final statistics tell the story completely. 118 Type 21 boats completed, 4 combat-ready, 2 operational patrols, 0 ships sunk, massive investment of resources, labor, and expertise for no strategic return. The contrast with earlier German submarine operations is profound. Between 1939 and 1943, German U-boats sank thousands of Allied merchant ships and hundreds of warships. The Type 7 and Type 9 submarines, though technologically inferior to Allied late-war designs, achieved strategic impact through their deployment in sufficient numbers at the right time. The Type 21's failure to influence World War II should not obscure its revolutionary nature. The design was genuinely advanced. The concept was sound. The execution was sophisticated. Under different circumstances, with earlier development and reliable production, the Type 21 could have posed a severe threat to Allied operations. But circumstances matter. Timing matters. Industrial capacity matters. And by 1944, Germany lacked the time, resources, and industrial capacity to deploy revolutionary technology effectively. For the Allies who studied captured Type 21 boats after the war, the relief was mixed with respect. Allied engineers recognized immediately that German designers had solved problems that Allied submarine forces still faced. Streamlining, battery capacity, underwater speed, silent running, the Type 21 addressed these challenges comprehensively. That it arrived too late to affect the war was fortunate. That it influenced post-war submarine design so profoundly was inevitable. The evolution of submarine warfare from World War II through the Cold War and into the present can be traced directly to Type 21 innovations. Modern submarines are faster underwater than on the surface. They operate primarily submerged. They emphasize stealth over surface gun armament. They incorporate streamlined hull forms with minimal protrusions. These characteristics all derive from German engineering work between 1943 and 1945. The Type 21 established the template that nuclear submarines would perfect a decade later. The story ends where it began. U-251, approaching HMS Norfolk on May 4, 1945. 17 knots submerged, undetected penetration of escort screen, perfect attack position. The demonstration of capability that came too late to matter. Commander Seen's decision to spare the British cruiser represented both mercy and pragmatism. The war was over. Further killing would accomplish nothing. Better to demonstrate what might have been and let history judge. The British officers who later confirmed Seen's account faced the uncomfortable realization that German technology had outpaced Allied anti-submarine warfare in at least one critical area. If Type 21 boats had been operational a year earlier in meaningful numbers, Allied strategy might have required fundamental revision. That this did not occur was due not to Allied superiority but to German industrial failure and timing. The lesson was clear. Technological advantages are temporary. Industrial capacity is decisive. And in war, arriving late means arriving too late, regardless of how revolutionary the technology might be. The Type 21 represented a fundamental shift in how navies understood submarine warfare. Before its development, submarines were conceived as stealthy torpedo boats that happened to submerge occasionally. After examining captured Type 21 boats, every major navy reconceived submarines as underwater vessels that occasionally surfaced. This philosophical change proved more important than any specific technical feature. The speed differential between surface and submerged operations illustrated the revolutionary thinking. A Type 7 U-boat could manage 21 knots on the surface, but only 7.6 knots submerged. It was fundamentally a surface vessel. The Type TWE-21 achieved 15.6 knots surfaced, but 17.2 knots submerged. It was fundamentally an underwater vessel that could surface when necessary. This inversion forced Allied naval planners to reconsider every assumption about anti-submarine warfare. Convoy escorts were designed to be faster than submerged submarines. Most destroyer escorts could manage 21 to 24 knots maximum. Against Type 7 boats crawling at 7 knots underwater, this speed advantage was overwhelming. Against Type 21 boats racing at 17 knots, destroyer escorts were barely faster, and some could not catch the submarine at all. The tactical implications cascaded through every aspect of naval operations. Convoys traveling at 10 to 12 knots could be overtaken by a submerged Type 21. The submarine could position itself ahead of the convoy, attack from optimal range, and escape at high speed while reloading for a second attack. Previous U-boats had to surface to reach attack positions, exposing themselves to radar and air patrols. The hunter-killer groups that had proven so effective against conventional U-boats faced severe challenges against Type 21 boats. These groups combined escort carriers with destroyer escorts to locate and destroy submarines. Aircraft would spot submarines on the surface. Surface ships would pursue and attack with depth charges and hedgehogs. The system worked because submarines had to surface regularly and were slow underwater. A Type XXI could remain submerged for days using its schnorkel. When detected, it could escape at speeds approaching those of its pursuers. The hedgehog and depth charge attacks that devastated conventional U-boats were far less effective against a target moving at high speed and maneuvering aggressively. Allied doctrine assumed submarines would try to evade slowly and quietly. The Type XXI could evade quickly and still remain relatively quiet due to its streamlined hull. The acoustic signature comparison between Type 7 and Type XXI boats revealed another advantage. The Type 7 generated significant noise from its electric motors and propellers at speed. Allied sonar could detect these signatures at considerable range. The Type XXI's streamlined hull reduced turbulence dramatically. Water flowed smoothly along the hull instead of creating eddies and vortices. The noise reduction was substantial enough that Allied sonar operators trained on Type 7 signatures would have struggled to detect Type XXI boats at normal ranges. The strategic bombing campaign that had proven decisive against German industry paradoxically both enabled and prevented Type 20I deployment. Bombing forced Germany to disperse manufacturing, which led to the modular construction approach. But bombing also destroyed the infrastructure needed to implement modular construction effectively. Rail lines were bombed, factories were damaged, skilled workers were killed or diverted to repair efforts. The Valentin bunker near Bremen illustrated this contradiction perfectly. The massive reinforced concrete structure was designed specifically to protect Type XXI final assembly from Allied bombing. It featured walls and roof thick enough to withstand standard bombs. The facility would have allowed continuous submarine production regardless of air attacks, but construction required enormous resources that Germany could barely spare by 1943. When British bombers dropped Grand Slam earthquake bombs on Valentin in March 1945, the facility was 90% complete. The Grand Slams, weighing 10 tons each and designed to penetrate hardened targets, caused massive structural damage. Work was abandoned. The Allies captured the facility weeks later. The bunker that was supposed to protect Type XXI production from bombing was destroyed by bombing before it could produce a single submarine. The contrast between German and Allied industrial approaches extended beyond submarines to the entire war effort. Germany focused on producing small numbers of advanced designs, Panthers and Tigers instead of hundreds of thousands of simpler tanks, jet fighters instead of thousands more conventional aircraft, Type XXI boats instead of more Type 7 submarines. This approach reflected German engineering culture and industrial limitations. The Allies, particularly the United States, focused on producing adequate designs in overwhelming quantities. Sherman tanks were inferior to Panthers, but America built 50,000 Shermans. P-47 Thunderbolts were outperformed by late-war German fighters, but America built over 15,000. Destroyer escorts were slower than destroyers, but America built 563. The industrial philosophy prioritized quantity, reliability, and ease of production over maximum performance. This fundamental difference in approach determined the war's outcome more than any specific weapon system. Germany's Type XXI boats were superior to Allied submarines. Germany's jet fighters outperformed Allied piston-engine aircraft. Germany's heavy tanks dominated Allied armor in direct combat. None of it mattered because Germany could not produce these advanced systems in sufficient numbers to offset Allied numerical superiority in adequate systems. The human dimension of the Type XXI story reveals the desperation of Germany's final war years. Crews assigned to Type XXI boats were told they were receiving the wonder weapon that would restore German naval supremacy. They believed they would reverse the course of the Battle of the Atlantic. They trained intensively on complex systems, while Soviet artillery boomed in the distance and Allied bombers destroyed their bases. The psychological burden on these crews was immense. They knew Germany was losing. They saw cities burning. They witnessed the industrial collapse. Yet they were ordered to believe that advanced technology would somehow produce victory from certain defeat. The cognitive dissonance between observable reality and official propaganda must have been severe. When U-2511 and U-3008 finally deployed in early May 1945, their crews knew the war was effectively over. Berlin had fallen. Allied armies were overrunning Germany. The surrender was days away at most. Yet they conducted their patrols professionally, demonstrating capabilities that would have been devastating if deployed a year earlier. The dedication to duty in the face of certain defeat speaks to military professionalism divorced from strategic reality. The story of the Type XXI ultimately illustrates that revolutionary technology cannot overcome fundamental strategic and industrial disadvantages. Germany in 1944 faced enemies with superior resources, industrial capacity, and geographic advantages. No submarine, however advanced, could reverse those realities. The Type XXI might have prolonged the Battle of the Atlantic, It might have inflicted additional casualties on Allied forces, but it could not have changed the war's outcome because the underlying factors that determined victory were beyond any weapon system's ability to influence decisively. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.